In this video, we'll talk about finding derivatives for general logarithm and exponential functions. So we can use our work before, knowing what happens to the log when we take the derivative, the natural log, and our rules for exponentials, along with the chain rule and normal log rules, to figure out take derivatives of general logarithm and general exponential functions. So for instance, if I look at, say, log base b of x, assuming b is not e, is at the natural logarithm here, I want to take this derivative. How can I do that? Well, if I use the change of base formula, I can convert this into a natural logarithm, and that know the derivative of. I can write this as the natural log of x over the natural log of b. I want to differentiate that. Well, log of b is a constant, so that can come out front, 1 over natural log of b. And then I have just derivative of natural log. That's just 1 over x. So I get 1 over log of b times 1 over x. For that derivative, there is rule 1 that we get. And we do the same kind of trick with exponentials with a slightly different approach to it. So if I want to find the derivative now of, say, a to the x for some constant power a, I want to rewrite this somehow. And the way we can rewrite this as this is e to the x times log of a. This basically comes down to the fact that log of a to the x is x log of a, because powers can jump outside of logarithms like that. And so if I want just a to the x, I can exponentiate both sides of this to get me back to a to the x. These are equivalent here. But now this I can differentiate by chain rule. This will be an e to the x ln a, where my inside function here is x ln a. The derivative of the inside is just log of a, because that's a constant. This here converts back to an a to the x, meaning my answer here is log of a times a to the x. If I want to differentiate something of the form a to the x, that is log of a times a to the x. If I want to differentiate log base b, I get 1 over log b times 1 over x. There's our two formulas there. Now I want to find these two derivatives, the derivative of log base 2 of x squared plus 3, and g of x, which is 3 to the 2x. So for f of x, this is the chain rule problem. I have log base 2 of stuff. So what I should get is 1 over log of 2 times 1 over stuff, and then times the derivative of the inside, which is 2x. So I end up with 2x over x squared plus 3 times log of 2 for that. And for g, we can actually solve this two ways. So we could do it directly as is with the chain rule. So g prime of x, the function was 3 to the 2x. So I'm going to get, the outside part is 3 to the stuff. So I'm going to get a log of 3 times 3 to the stuff. And then times the derivative of the inside, which is just a 2. So I'll get 2 log of 3 times 3 to the 2x. Another way is we could rewrite this function. 3 to the 2x is 3 to the 2 to the x, which is 9 to the x. We can also find g prime as 9 to the x, which is just going to be log of 9 times 9 to the x. And using power rules and log rules, these two things are equivalent, because 2 log 3 becomes log of 3 squared, which is log of 9. So either of these here would work for an answer to this problem. If you want to simplify first and then differentiate, or just differentiate as is using the chain rule, both work out totally well for this kind of a problem. That's like we can use our properties of logs normally, plus knowing the derivative for log of x and e to the x, to figure out derivatives for general logarithm and exponential functions.